Date and time, which for simplicity here I'm going to just call time, are some of the data types that I consider special. Probably it is because it's the most human of all the data types, given a unique understanding as a species of time. Time is so complex that humans have many ways to represent time, including that we speak in times of relationship to when something happened or is going to happen. For example, we say 3 weeks ago, or next day, or in a couple hours. So we're constantly applying labels to time frames that are constantly changing. The day before for today means, I don't know, yesterday, but then the day before for 2 days from now means tomorrow. So it's a label that is constantly changing. Time is so complex that dates don't fall in the same day or week of the year. It's not really even a square measurement. So we know that 30 seconds is half a minute, 60 seconds is a minute, 60 minutes is an hour, 24 hours is a day, 30 or 31, depending on the month of the days, is a month, and 52 weeks is a year, and it's not necessarily always 360 days for a 365 days for a year. It depends on the type of year, if it's a leap year or not. So dates are complicated. And for example, January 1st of 2019 was a Tuesday, but in 2020 will be a Wednesday. Dates can be represented in many ways and formats. For example, May 8, 2014 or 05/08, 2014. Both are the same date and just written completely different. Internally, the computer keeps track of time as a counter of milliseconds that have happened since January 1st of 1970 GMT. The computer does several jumps to translate between dates and time zones and stuff like that, especially now that Java has evolved as a language and the world has become more global. Currently, the date object has just become a little bit more irrelevant, and if you see the API, you're going to see that a lot of the methods are deprecated because of the same thing. It is now only a representation. Classes like calendar or instant or other time zones have emerged to represent time in a much more accurate. The class called calendar allows you to manage dates in a very similar way that you manage your date in your calendar. The class called calendar is a class that allows us to manage dates in a way that we handle our calendar in our phones. On this class, we can perform time operations. For example, let's assume that we have the following class. In this class, we're creating a new date object that represents the current second of execution. The other one is a date that represents November 22nd of 2017. The next one is just a difference in time of how many days have happened since today is July 8, 2019 and November 27th. So we're going to compare the difference in the number of milliseconds. We are going to divide it by 1,000, which means now we're in seconds, divided by 60, which means now we're in minutes, we divide by another 60, now we're in hours, now by 24, which now in days. So the number of days that we have that have happened between July 8 of 2019 and November 22nd of 2017, it is a staggering 593 days. Let's assume that we have then another kind of object where we're gonna try to read a string like we write certain months and dates. So we're gonna receive 2 digits that represent the month, 2 digits that represent the date, and 4 digits that represent the year. We're gonna look at the time when the time machine was invented, and if we do print out n, we're gonna see that the time machine was invented. Oh, and this needs an exception to be handled, so we'll do alt enter and surrounded by try catch, and we essentially, in this case, we're gonna put the parser exception, and we can see that the date was successfully parsed. The last item that I want to talk about is essentially talking about the same date, which is let's say that we're going to set up a calendar, and we're going to import the calendar class, and we're going to set the time for we're going to just add 1 day to the time machine invention. So then we'll do cal.get time to get the date that the calendar has. Essentially, like if we have something like if we selected this date and we just keep jumping around from in the calendar. So it's, if we do get time, it's going to return the date that it's selected, similar to our calendar. So I am going to run this code, and I'm going to discover that it's November 6th because we added 24 hours to the date. And this is where the calendar function becomes, the calendar object becomes really convenient, because we can change it and say we're going to add 10 years. So we're going to get November 6th, 1965 as the result. November 6th, 1965. Yeah, it's actually pretty cool and convenient. We know that every time that we use a new keyword, a new string object is actually allocated, and that's why that string, compared to the original literal, was returning false. Strings are special objects since the inception of Java. So much that we can define strings without having to use a constructor. For example, we can use double quotes to define a string, and this will be known as a string literal. Strings can change, or in fancy terms, they're immutable. Every time we concatenate or create a new string, it is basically a new string. With immutability, Java can optimize the way that they are stored and places them in a special part of the memory in the JVM called the string pool. Strings created during the new keyword are allocated as new objects. So this is what this interning thing is. Essentially, we're creating two strings with the same string over, and if we run them with as a comparison just to see if they are the same object, it's going to return true. Actually, even if we run the debugger, we're going to realize that the string is actually putting the same character arrays into the same ABCD. It's the same object, exactly the same. Now, what would happen if we say created string C equals new string, and we did ABCD, and then compared to see if A is the same as C, just like we did with A and D. So just notice that they have the same content, and the result is false for this guy. If we want to intern the string, we can use the method intern. We need to be careful not to fill this buffer, as it is not eligible for the garbage collector. We can risk an out-of-memory error. What would happen if we wanted to intern this guy and put it as string D? Is essentially, and then we're going to compare A against D. That means that we're going to force push the contents of this string to the cache, and now let's compare both objects. Now those two objects are the same as this guy, as A and B. Given that strings are immutable, there are ways to make strings faster and in a more performant way. These are the string buffer and string builder classes. These are useful when reading a long file or data from I/O, and we will want to keep things performant and not in a bottleneck. String buffers are thread safe and synchronized, while string builder are not. Let's look at a comparison of performance for both classes. So in this exercise, I do have a string that I'm gonna be concatenating 16,000 characters, and I'm just gonna be concatenating strings from A to Z, just by going A, B, C, D, E, F, G, all the way to Z. And I'm measuring the time before and after, before I start concatenating them and after. Then the next time I'm gonna do the exact same thing. I'm resetting the first character to be A, and then concatenating all those but using a string buffer. And then the last time I'm gonna do the exact same thing but using a string builder. And in these cases, you can see that I'm using an append method as opposed to the plus equals. And if we ran these strings, we're gonna get a elapsed time for just using a string, and then the number of nanoseconds using a string buffer, and then the number of seconds using a string builder. Now, Java is really, really fast, and some of these might not even matter because it's still quite fast. but you can see that the string was actually dramatically slower than a string builder. So if you're dealing with very large amounts of text, it's actually much more performant to handle everything, or the concatenations and management of the strings, using a string builder or a string buffer, and then just using that to convert to an actual string. It's dramatical, the difference between both. Java includes support for regular expressions, or regexes, using classes to compile the regexes as a pattern, and classes for evaluating and matching the regular expressions. For example, let's try to match an email to a regex. In this case, we have defined, by using our handy table that we have here, we are going to see that a dot, in this case, we're saying that this guy is the first character. If you see in our table, it's the beginning of the line. So the line has to start with any number of characters, find an @ sign, be followed by any number of characters. Then this is going to tell it that we're looking for a dot. So the backslashes are telling it that, oh, by the way, start looking for a dot rather than just any characters, because the dot means in regular expression language that it's any character. But here we're using the backslash dot to say that it's going to be a dot and then any number of characters, and then an end of the line. So for example, once we have that regex defined, we can pass it to the pattern compile function, and it's going to return us a regular expression. Then we're going to input a string and match it against that compiled pattern and see if it matches. And the answer is true. Again, we're looking at the beginning of the line, a set of characters, followed by an @ sign, followed by a set of characters, one or more characters, a dot, and then followed by other characters. Regular expressions allow us to extract popular values from strings. For example, we can extract the video ID from a YouTube URL. So here, we're going to try to look for the string the string watch, and then the question mark. So we're saying like, oh, market, this is going to be not a regular expression match. It's just I want you to really look for the question mark. That is essentially like saying use the question mark and then v equals, and then a series of any characters that are word-like. So if we look at this table, it's any word character. So it's from 0 to A to Z, uppercase and lowercase, and 0 to 9. So it matches that. But this actually says find 11 characters, which is what we have in here. So then we're going to pass that regex, which is a formula for this string, and we're going to say that we don't really care about it being case sensitive or not. So we're going to say just match what I'm telling you, don't care about the case. Then the matcher is going to try to find the patterns, and if we find a match, we're going to return the groups, which the group is defined by these parentheses. Anything that is in parentheses is going to be the group. So we're going to find the first group, and that is going to be what the value of the data is. So, and it's going to return ID, which is what I'm printing here, and the first group, which is the ID of the video. So you can see how it's a way that I'm extracting just this portion and discarding everything else from the string. If you found this video useful, give it a full thumbs up. If you want to get notified about these videos as soon as I upload them, just subscribe to this channel.